Hi guys, I'm hoping to be back soon, but I thought I'd get you started out just in case I was running a little bit late. Make sure that you either have a paper copy or the Schoology copy, electronic copy of this. And if I'm ever going too fast, feel free to pause it. If you ever want to just go on your own, pause it, and let's go from there. Okay, number 1 and 2, if I were there, I would be having you try on your own, so feel free to pause it if you want, but I'm going to go ahead and do this. Root 3 minus 2 times root 3 plus 2, something that comes to mind is up. They're conjugates. I remember conjugates. You know, the outsides and insides are gone. Therefore, when I multiply these, I end up with 3. Oops, I actually want red. I end up with 3 minus 2 times 2, or 4, and I get negative 1. Kind of nice in this situation. Because they're conjugates, they got rid of those radicals. Now 5 root 3 minus 4 squared, not as nice, but 5 root 3 times 5 root 3 is 5 times 5 is 25. Root 3 times root 3 is 3. Now on my outsides, I'm going to get 20 root 3 minus another 20 root 3 plus our 16. We end up with 75 and 16, or 91, minus 40 root 3. Okay, the big idea for today is that you are never allowed to have a radical left in the denominator. When simplifying radicals, we are not allowed to have radicals in the denominator. We do this by rationalizing, that is, multiplying by a form of 1. So we'll start off with some easier ones and then work our way to the more advanced problems. But directions. Rationalize the denominator of each radical expression. Assume all variables represent non-negative numbers and that no denominator will ever be 0. Okay, when I do the first one, cube root of 2 over 27, that's really the cube root of 2 over that cube root of 27. And the good news here is that the cube root of 27 is just 3. Therefore, I get cube root of 2 all over 3. No need to rationalize. Number 4 is an Algebra 1 topic, and you dealt with this in geometry as well. 3 over root 5. Well, I cannot work with this because I have a radical in the denominator, and I cannot simplify that root 5. Therefore, I'm going to take and I'm going to multiply this by root 5 over root 5. I have to do this because that is a form of 1. I have not changed the problem. Now, I'm going to show more work than you probably ever would, but this gives me 3 root 5. Now, the whole purpose of us multiplying by root 5 isn't just because that's what was in the denominator. It's because we've now created the square root of 5 squared. The square root undoes the square, and we're left with 3 root 5 over 5. And I'm going to come back to that in a few examples. Okay, square root of 7 over 2x, I'm going to rewrite it as the square root of 7 over the square root of 2x. Well, I do not know the square root of 2, and I do not know the square root of x. Therefore, once again, I'm going to rationalize. I'm going to multiply by the square root of 2x over the square root of 2x. You do not need to use this or show this next step, but this turns into the square root of 14x over the square root of 2 squared x squared. This is once again my point. I needed to create something squared so that when I took the square root, it would come out nicely. And I'm left now with the square root of 14x all over 2x. I cannot do any more simplifying because 14x is under the radical and 2x is not under a radical. And now we get to the new problems. Everything else so far has probably been review. Now I have 1 over the cube root of 2. Now at first people always want to say, oh, just multiply by the cube root of 2. But if I do that in the denominator, I now have the cube root of 2 squared, which still cannot be simplified. Therefore, I always think about this, okay, I need to have the cube root of 2 cubed in order to take that cube root. Therefore, I'm going to go ahead and I'm going to multiply by the cube root of 2 squared. Think about it. So I need 3. I had 1 looking at the exponent, and I need 2 more. Now that gives me the cube root of 4 up top over the cube root of 2 cubed, not needed step, but we end up with the cube root of 4 all over 2. Okay, similar idea for number 7, just a little trickier. This is the 4th root of 3 over, I highly recommend breaking that 8 down into 2 cubed. Otherwise, you're multiplying by 8 cubed, which who wants to deal with that? Therefore, right now I've got 2 cubed x squared. Okay, to rationalize this, I need, something to the 4th power. I already have 2 cubed, which means I need 1 more 2. And I've got x squared, so I always think about I need that another 2 more. Therefore, I'm going to multiply by the 4th root of 2 to the 1st, x to the 2nd. That will complete my getting to those 4th powers. What I do to the bottom, I must do to the top to keep it balanced. And I now have the 4th root of 3 times 2, 6, x squared, over that 4th root of 2 to the 4th, x to the 4th, which the top cannot simplify anymore. I've got the 4th root of 6x squared, but the denominator, the whole goal, can be simplified into 2x. Therefore, I'm left with the 4th root of 6x squared all over 2x. Okay, number 8, if I were there, I would prefer you guys trying this on your own, so why don't you guys go ahead and pause this. I'm not going to just sit here and wait, but pause. My only advice, though, would be that there's many ways of doing this, but personally, I see an x cubed and an x to the 8th. I can reduce those, a y to the 7th, a y to the 5th. I would reduce, then worry about rationalizing. Okay, so go ahead and pause. What I'm going to do is I'm going to reduce. I'm going to treat it all as 1. I'm going to say that's the cube root of 16 over 5. That x to the 5th will be in the bottom, and we'll have a y to the 2nd on the top. Now I'm going to go ahead and say, okay, that's the cube root of 2 to the 4th, y to the 2nd, over the cube root of 5x to the 5th. I'm taking a lot of time on this one. I'm showing a lot of work at least. Now, simplifying that down just a little bit. You don't have to, but I recommend it. 2 cube root of 2y squared. Can't do anything with that 5, but I certainly can take the cube root of x to the 5th to get x. And I'll be left with the cube root of 5x squared. Still nasty, but a lot nicer to work with. Now, I'm going to take the cube root. We'll have a 5 to the 1st, which means I need 2 more, therefore 5 squared. I have an x squared, which means I need that 1 more. What I do to the bottom, I must do the top. And let's see what we're left with. 2 still on the outside. Cube root 2 times 25, or 50, xy squared. I have the x already. I'm not going to show all the work here because we know this is the cube root of 5 cubed, x cubed. Therefore, it's times 5x. And finally, simplifying it down, we get 2 cube root of 50xy squared over 5x squared. Okay, this one's kind of a review from the other day. The 12th root of 3 to the 4th, at first glance feel like can do nothing, but then you see that they're both divisible by 4. Therefore, I'm going to rewrite this as 3 to the 4/12, change it to rational exponents. And now I'm left with 3 to the 1/3, and that is the cube root of 3. Okay, Number 9, or excuse me, number 10 and 11 is very important that you notice the difference of how to deal with these. Okay, 10, 2 over the square root of all of x plus 5, compared to number 11, 2 over the square root of x, then plus 5. So please, please, please notice the difference between these two. In 10, there's a radical over the whole denominator. In 11, it's just over one of the terms. So here we go. When I look at 10, this should be old news. I have the whole square root of x plus 5, so I'm just going to multiply by x, the square root of x plus 5 to the top and bottom. And we're now left with 2 square root of x plus 5. And then we get the square root of x plus 5 times the square root of x plus 5, which is just x plus 5. As opposed to something like number 11. Now, if I was there normally, I'd be taking lots of suggestions, and I'd be getting people to say square root of x, or just 5, or all that different things. But think back to number 1, if you flip over there. By multiplying by the conjugate, we were able to eliminate all radicals in the denominator. Therefore, we're going to do the exact same thing. We're going to multiply by the square root of x minus 5. And look what happens. Up top, it's not great, but we get 2 root x minus 10. But in the bottom, it's awesome. Square root of x times square root of x is x. Remember, outsides and insides cancel out because we've got conjugates, and then we've got minus 25. Doesn't look beautiful, but we were able to get rid of our radical in the denominator. Okay, super important for that one. 2 root x minus 10 all over x minus 25. Okay, the same idea for number 12. We've got x over 5 root x plus 3. I'm going to go ahead and multiply by that conjugate. 5 root x minus 3 over 5 root x minus 3. Up top, we'll get 5x root x minus 3x. And then the bottom, we'll get 25, just x. Outsides, insides cancel, and we'll have minus 9. Up top, I see I can take out that GCF of x, so that makes sense since it was x times, the 5 root x minus 3. But there appears to be nothing in the denominator, so that is our final answer. 5x root x minus 3x over 25x minus 9. Okay, 13 I want you guys to try on your own, so whoever's here playing this, if you can, pause it and then check my answer and obviously my solution. For this one, I'm going to multiply by that conjugate of 5 plus root x plus y all over 5 plus root x plus y. And we'll be left with 10y plus 2y root x plus y. In the denominator, 25. Outsides, insides cancel. And we're left with minus the quantity of x plus y. Therefore, we get 10y plus 2y root x plus y all over 25 minus x minus y. Okay, last ones are not to deal with rationalizing. They're just to talk about adding or subtracting radicals. In order to add or subtract the radicals, you must have the same thing, term, numbers, whatever, underneath the radical, the same radicands. Okay, so first always go ahead and simplify and see if you can combine them. Y cubed root of 16x to the 8th y plus x squared cubed root of 54x squared y to the 4th. So I'm going to kind of deal with this like two different problems. I'll have y cubed root of 2 to the 4th x to the 8th y. I'll just simplify this one as I go. And I'll get, let's see, 2. I have a y already out there. 3 goes in 8 twice, so I'll have x squared. And I'll be left with that remainder of the cube root 2x squared y. Now move into our next term. We'll have plus that x squared that's already out there. 54, I don't recognize quite as much as 16, but since it's a cube root, my mind goes 2 cubes 8, 3 cubes 27, 4 cubes 64, that's too much, so thankfully 27, 3 cubed, goes into 54 2 times. And now let me simplify. I'll have plus 3x squared y, and I'll have the cube root of 2x squared y. Well, good news here is that I have the cube root of 2x squared y and the cube root of 2x squared y. So they can be combined if now the numbers in front of them can be combined. They're a little bit out of order, but I have a 2x squared y and I've got a 3x squared y. Oh great, like terms. Therefore, they can turn into 5x squared y cube root of 2x squared y. Once again, pause at any time. I'm not putting a ton of breaks in between things, but you can always pause if need be. Last one, same idea. Okay, 256. Any recommendations on that? 256. 256 is 16 squared, or better yet, we end up with 4 to the 4th, x to the 5th, y to the 6th, plus that 4th root of, well, 625. 25 squared, which is 5 to the 4th, x to the 9th, y squared. Okay, simplifying this down, we get 4x, y, 4th root of x, y squared, plus 5x squared times the 4th root of x, y squared. Okay, great. I've got the 4th root of xy squared, and I've got the 4th root of xy squared. Now I look at 4xy, and I compare it with 5x squared, and notice even though they have like radicands, they cannot be combined, and that is our final answer. Okay? Hope this worked for you, and I'll see you guys soon.